Caitlin received $5,400 cash for wedding gifts from her rich relatives. She and her new husband want to invest 40% in an account earning 2.1% interest compounded continuously. The remaining 60% will go in a money market account earning 2.75% interest compounded quarterly. How much money will each account have at the end of 10 years? Caitlin is hoping to have enough money to make a $10,000 down payment on a house at the end of the 10 years. Will she have enough money? Find the APY for each account. Note, use only the simple, general compounding or continuous compounding formulas for APY. And that means figure out which one of those three is appropriate for this problem and then use that formula. So if you're doing a loan or an annuity, then you would always use the general compounding formula for the APY. And in this case, we have to figure out first what formulas are we going to use. Well, I see here compounded continuously, so that tells me that 40% of the money will be compounded continuously, and the 60% account says compounded quarterly. So I know that compounded quarterly is telling me that it should be the general compounding formula. The other clue I have is that she has a lump sum of money, $5,400 in cash. That's a big chunk of money that she wants to deposit somewhere and just leave it sit. She's not going to make $5,400 payments every month because obviously she just got the $5,400 in cash and that's all she has. Okay, so we're going to have two accounts. How much money will each account have at the end of the time? So first account is going to be 40% of the 5,400, and to find that I'll just do 40, use my percent button, times the 5,400, and I get 2,160. And then I also need 60% of the 5,400, so I can do it this way, doing the 60% times the 5,400 and get 3,240, and those two numbers should add up to the 5,400, so I'll just check that real quick. Plus 2,160, and I get the 5,400. That's good. So I have 2,160, 3,420. The 2,160 is going into an account that is continuous, so that's going to be future value, or I think we have A on our formula sheet. Present value times e to the RT. That's the PERT formula. And here's the continuous compounding right here. The A equals present value times e to the RT. And then we also need a general compounding formula, and I don't know which one of these two, but I think it's going to be the first one, the A equals, because I think we're trying to find an ending amount for both of these accounts. So let's take another look. And so for general compounding, it is the A formula because we do want to end up with, we want to know the amount of money that we'll end up with, and we know our starting value for the account. So it's the PV times 1 plus R over N raised to the NT power. And I know that one by heart, so I can just write it out. Okay, there's my formulas. And then I need to start figuring out what values go where. So for that first formula, I'm going to see if I can just write it out here. The present value, that's the 2,160 that we have. And that I'm double checking that does say compounded continuously for the 40%. So that will be 2,160 times e to the R, which will be 0.021. And the T is there, it says it in part A that it'll be 10 years. And 0.021 times 10 gives me 0.21. And then I have to do e to the 0.21. So I can do second ln and then second answer and then equals, and I get that 1.23367, and I snuck in a 0 there, so it's actually multiplied by 2,160, and we will have an ending amount of $2,664.74 with a 4 following, so it's going to stay a 4, not be bumped up. For the second formula, I'm going to write it down below. That one I had 3240 to start with, 1 plus my rate. For the second account, I can see here is the 2.75%, so 0.0275. The compounding, ooh, this one's a little different. This one is quarterly. That means my n has to be 4. Remember, that goes in 2 different places, so I put a 4 here, and then an n again here, and times 10 for 10 years, so that's going to become 40. So we've done a lot with compounded monthly, but if you have a different compounding, remember the n goes here and here, and that'll be 4 in this problem because of the quarterly compounding. So then I have 3240 times 1 plus, I have to do the 0.0275 divided by 4 equals, and I get the 0.006875 to the 40th power. So before I can do the 40th power, remember I have to add 1, and then now I can do to the 40th. And last thing I want to do, maybe write out one more line and put, there we go, then finally multiply by 3240. So that is going to give me an A of 4261.54, but then I have a 7 following, so that has to bump up to a 65. And the question was, how much will she have, how much money will each account have at the end of 10 years? So this will be 2,600, this will be 4,200, and this one is in the first account, and this will be the second account. That's how much each account has. And then we were being asked, part B, Caitlin wants to have 10,000 for a down payment. Will she have enough money? So we're going to just add those two accounts together, 2664.74 plus, and the second account is $4,261.55. And so together, I'll put it over here. She's not quite there. She only has $6,900. She will not have 10,000. Okay. And then part C, we're supposed to find the APY for each account. So let's take another look at that formula sheet. And APYs, here we go. APYs for general compounding and APYs for continuous compounding. So I'm going to copy both of those because I have one of each account type, that is. And let's see if I can just pop that down here. So for the general compounding account, I have to use all the information that we were given for that account, not for the continuous account. And same for the continuous account. And since we started talking about the 40% in a compounded continuously account, I'm going to start off with that one for the APY. So that one will be APY percent equals e to the r minus 1 times 100. Easy enough. And so my next line is going to be e to the r for that account. I have to scroll up just a hair, was 2.1%. So it's 0.021, and subtract 1 and then multiply by 100. So I need e, so I do second ln, that gives me e to the, and then 0.021 for the exponent equals, and it's 1.02, and then I'll subtract off that 1 and multiply by 100. And there I get 2.1222% APY. That's for the first account that was described. The second account, remember, I'll need to use the general compounding because it does say compounded quarterly for this account. And so that one's going to be APY percent equals 1 plus r over n to the n power minus 1 times 100. And the values I need to plug in are 1 plus my rate was 2.75, so 0.0275. My n, remember this was an unusual n, so it was a 4 for quarterly, to the n power, so it's going to be to the 4th power minus 1, and then finally multiplied by 100. So working inside the parentheses first, I'll do this fraction 0.0275 divided by 4, and then finally add 1. That'll take care of everything inside the parentheses. Raise it to the 4th power, and then subtract the 1, and finally multiply by 100. Now I'm left with 2.7784, but there's an 8 following, so I'll change it to a 5% APY. And that's for the second account.